18.
Mr. Murphy, I think you scared Hunter into not coming today.
Well, I didn't need to. I just wanted him to stop acting like a moron. Stop acting crazy. You don't need to. All right, let's walk through this. So as you go through the objection function, excuse me, not the objective, you go through the constraints. Shh, guys, we have a lot to do today. We start to think these out, as we do always, as we start to visualize our graphs. We're doing rough sketches here. In this case here, it looks as if we have our x values are greater than or equal to 0. Just from that bit of information tells me I could be first or fourth quadrant. After that, I go to the next values. It says y is greater than or equal to 0, which means I'm no longer in the fourth quadrant. I'm a first quadrant problem. But y is less than or equal to 8, so I'm going to put a line here at 8. So I'm bounded in this region right now. After that, I start walking out and figuring out my x and y intercepts. First one, I have x and y intercepts at 14. And then the next one, I have x and y intercepts at 10 and 50. Thank you, sir. It doesn't look pretty at all, does it? That one should be.
Yeah, the 8 should be higher. I got it.
Well, and here's one way we can figure this out where things lie. Because even though our graphs look pretty crummy, what I do know is that 8 passes through both of these, right? The 8 goes through both of those two lines. So what I can do real fast, just by looking at it, is I can get these two ordered pairs without too much of a hassle. I know it's going to be something, comma 8, and something else, comma 8. And that'll help me determine where it kind of lies within the shade region. 8 plus what is 14? 6. So that's for this one. And the other one is,
You can do that?
that's what you're supposed to do.
Oh.
I just tried to guess like.
And the other one is like 8 point something. Yeah, so that way, this basically is showing me that my graphs are pretty bad.
My spot where they intersected was like at the bottom.
What's that?
My spot where the two lines intersected was like
Inside here?
No, like at the bottom, like down where the 10 and 14 are.
Yeah, sometimes if you wind up with a far out intercept, so we'll make this one a little bit cleaner. We'll say 50 is way up top, and we'll start backwards. 50, and then we'll go 10. Maybe this will help clean it up. And then 14, 14. Every once in a while, you get a problem where no matter what you do, the scaling of it, of how you draw it, might make your lines just look all out of whack. All right. Just with those two lines right away, with those two lines, I can find that intersection rather easily. X is 14 minus y. Do you agree? And then I can substitute into here. So I have 5 times 14 minus 5y, minus y plus y is 50. What is that? 90 minus 5. So it's 90 minus 4y is 50.
Would it be 70?
Math wasn't my strong suit. So I have 5 for a y. Okay. So the y value here is 5. The x value is, well, what plus 5 is 14? 9. So what I did is I just found that intersection first. Now I know that, excuse me, the y is less than or equal to 8 have to be above that line. Do you agree? And the reason it has to be larger than that because 5 is a y value 8 is a y value. And this thing is working inward here. So all I need to do is find that point there. So it's going to be this coordinate. So you wind up with those, what is it, 1, 2, 3, 4, 5 spots. One of those ordered pairs is 0, 0, 10, 0, 9, 5, 0, 8. And then if you put 8 in for x, 8 plus what is 14? 6. So you're checking.
What maybe 6, 8. Oh, wait, no.
Yeah, thank you. 6, 8, thank you. 10, 0, 9, 5, 6, 8, and 0, 8. So you check all 4 of the, or 5 of those, excuse me, check all those 5 values with your objective function to figure out which one is your maximum, which one's your minimum. So if you get lost in your drawing, if it doesn't work out real well, if you start with the ones that have the worst looking intercepts and then scale it back to that. Sometimes it's a little bit cleaner. Let's do another one.
20.
8, 20?
Yeah.
Was it hungry?
No.
8.
Sounds so funny.
I'm not fun. All right. Don't freak out if you got a fractional intercept. It's not a big deal. Not a problem. Do we agree first quadrant problem?
Yeah.
All right, so we start with first quadrant. Negative x plus y is greater than or equal to 0. I'm going to come back to that. I'm going to come back to that one, because that's the same thing as saying y equals x, isn't it?
Yeah.
All right, so I'm going to come back to that one. Well, you know what? Never mind. Y equals x, slope of 1. It cuts this right in half. Do you agree? Yeah. All right, so it's a lot easier. A point that's not on y equals x. 0, 5? Is 0 plus 5 bigger than 0? All right, so we're looking at this wedge. I'm looking at that 45-degree angle. Because it's cut the quadrant in half. Geometry, synergistic completion. The next one we have x and y intercepts of 2 and 4. This one is going outward. 0 plus 0 is not. So right now I'm in this region, so I have to worry about this point here. And then the next one I have x-intercept of 6.5, y-intercept of 13. And that one's working inward. 0 plus 0 is smaller than 13. So we have our spaces to worry about is in here. And the line that I'm going to use for substitution to solve for the ordered pairs is going to be the line y equals x. Because negative x plus y is 0. Move them over, use substitution. So to get this intersection point right here, that one was with this guy. So 2x plus x is 4. 3x is 4. X is 4/3. So if x is 4/3, what's the y value? 4/3. So you have an ordered pair at 4/3, 4/3. Start making a list. 4/3, 4/3. Next one, 0, 4, 0, 13. And then we do the same thing here. 2x plus x is 13. X is 13 over 3. Therefore, what's y? 13 over 3. And just use substitution into your objective function with those 4 points to figure out what your maximum is. You can get fractional things. It's not that big of a deal. You're just looking for approximation because it's asking you what is the maximum, what's the minimum, and that you just by identifying it, so all you have to do is basically plug and chug. Okay. I know some of you guys are still kind of glazed over on a little bit of this. Do these extra examples have helped? If you have screwed up stuff, that'll give you time to fix it for tomorrow. Okay? Well, I'm just saying, they'll collect this tomorrow in case people have to go back and fix it. Okay? Because today we're going to start with the word problems. Huh? Word problems. We're going to come up with our own constraints. We're going to come up with our own objective functions. And so far today, we've been able to get through quite a few of them without too much of a hassle. So here's what happens when you start dealing with these things in terms of word problems. What happens here is that you guys are now in charge of figuring out what is the objective and what your constraints are. So as we read this first problem, we're talking about a gift basket. And you're making a gift basket for your mom who's a reader. You decide to include hardcover and paperback books in the basket. You have $80 to spend. Hardcovers are 24, paperbacks are 8. The basket will hold at most three hardcover books and 7 paperback books. Find the maximum number of books you can include in the basket. No, we're not buying her a Kindle.
But it was such a great solution.
It was a great solution, but unfortunately it doesn't work. So when you're reading this problem, what is the objective? What does it tell you to find? The maximum number of books. So your objective is to find the maximum number of books. So your objective function, that C, if you will, we've been writing it out as a capital C, is to find the maximum number of books. Well, what are the types of books that you have? Hardcover and paperback. Is it okay if I use H&P? Yes, sir.
Wait, so the basket can only hold 3 assigned, or like the whole basket will be full with 3 of the hardcover books?
Or
Yeah.
it's
It won't be full?
it's a combination of the two. It's
So
a-
wait, so 10 books, 7
Yeah.
paperbacks, and 3 hardcovers will be filled.
But you only have a certain amount of dollars to spend. So this is where we start bringing the constraints. Your first, yes.
Can you say right away that it's like greater than, it's gonna be in the first quadrant?
Yes, and I'm getting there. But the first thing you're right, because you can't have negative amount of books. But the first thing that they talk about in this problem talks about money. Do you agree? And it says that you have how much to spend. All right, so if you have $80 to spend, can you spend more than that? Can you spend that amount?
Yeah.
All right, so is that a less than or equal to or greater than or equal to?
Less than.
Good. What are the two costs that you know? 24 and 8. So 24 for the hardcover books and 8 for the paperback.
Why would you buy a hardcover if you're just trying to get as many books as possible?
Yeah,
So-
buy all 10 paperbacks and you're good. That's why I was asking if the maximum was 7 paper, because then
You want a combination. I don't know, it's the problem. Stop being so literal. Independent thought. Now, the most you can have of the hardcover is how many? And the most you can have of the other one is, so H can't exceed 3, and the paperback can't exceed 7. Oh, sorry, I have that backwards. Excuse me. I was saying exceed, I'm thinking can't exceed, I'm thinking greater than, sorry. But like Richie said, can we have negative books?
Well, Richie can.
Oh, yeah, so you need
So you wind up with that setup. Now, just like we've done in every other problem, the next thing we did was just start plotting points. So I'm going to split this on a separate sheet. And like you said, it's a first quadrant problem. Now, since I didn't use X's and Y's, suggestion that I'll give you guys is, since we used H and P, we put H down first. Treat H as the X value, P as the Y value. Sometimes it's helpful to label them what variables you're looking at. It doesn't matter which axis you call which. As long as you're consistent, you're going to get the exact same result. You're going to get the same answer. Okay? I know that I had intercepts at 10 and 80 divided by 24 is? much? 3 1/3? So there's my intercept. And is that moving inward or outward for our shade?
Yes, you move.
I'm guessing you're right, because it says less than or equal to. It's got to be going towards the 0. Now I've got to be smaller than 3 for H. So I have an intersection point here. And I've got to be smaller than 7 on the p-value. So I have another one here.
But why is it 10? I thought it was going to be 7.
I graphed the first one first. The first.
Oh.
That's all. So that gave me this bounded area in here. There are 5 sides to that figure, so how many points of inflection should we have? 5 of them. We can find 3 of them real fast. 0, 0. I'm going to list them back over here. 0, 0. 0, 7. 3, 0. It's not 3 1/3 because I changed it because it's outside of that boundary. Okay? So now to figure out those other 2 points, it's going to be really easy because they're horizontal and vertical lines. You already know your x and y values at the intersection point. I know here at 3 is the x value when it intercepts that line. So if 3 is playing the role of h, 24 times 3 plus 8p is 80. Well, 24 times 3 is 72. 80 minus 72 is 8. And last I checked, 8 divided by 8 is
1.
1. There's one of the ordered pairs. And I do the same thing with the 7 for the y value. 8 times 7 is 56. 80 minus 56 is 24. 24 divided by 24 is 1. And from there, our objective function is really easy to use. We don't really need to even write it out. 0 plus 0, 0 plus 7, 3 plus 0, 3 plus 1, and 1 plus 7.
7 paperbacks.
And there's your answer. 1 hardcover and 7 paperbacks. That's how it sets up. What's that?
Wait, why like the profit all?
Books are different sizes.
I know. Don't think too literal. Just think about literary.
Wait. How do we decide that? How do we
We're using the objective function. The objective function is which one of these, if you add the 2 values together, is the biggest number. That's all. And in this case, I didn't write that step out because it's just 0 plus 0, 0 plus 7, and so on. Okay? Let's try the next one. By the time we get to this third one here, you guys will be fine. I'm not lying. Have some faith in yourself. Trust me. I have not steered you wrong yet today. Well, because you guys always bring back up the slope story.
You don't get one.
Yeah, we were looking why there's so many.
Oh, you get one? I'm sorry.
No, I was just in the big one.
Well, you just passed it.
No, I took one. I was like this.
He's just saying that you're very forgettable.
Yeah.
I'm sorry. Bless you. Now, we've all decided to make money selling doll clothes. We are going to sew a whole bunch of doll clothes to sell at a craft fair. We are making party dresses and casual sets, excuse me. Party dresses take 2.5 hours. Casual sets take an hour. You make a profit of $9 on each party dress and a profit of $4 on the casual sets. If you have no more than 30 hours available to sew, and you can make at most 15 outfits, how many of each kind should you sew to maximize your profit? Right away, what is your objective?
Figure out how many you can sell.
Let's start with P plus.
You're being too general. What is the objective here?
To money. How much money
Like,
we
they
can
get
make.
money.
Maximize your profit. The objective, your goal, maximize your profit. Think of it just along those lines. You want to maximize your profit. Lots of these things say maximum number of items, maximum sold, maximum profit, things like that. Now, when I want to talk about maximizing my profit, I go back to the problem, and I know it's going to be a capital C. What are the two values that talk about profit in here? 9 and 4. So I make $9 on the party dress and $4 on the casual dress. I know I'm using the letter C twice here, but are we okay, since the objective function is always defined by the capital C, are you okay if we using the small c for casual dress? Thanks. Now, what are the two things that it talked about? It talked about the hours that you have available and the total amount you can make. Do you agree? Those are your two constraints. Yes, sir.
Why dog food are they that? Is that business that profitable?
I don't know. Don't overanalyze. All right? And you're going to find out real fast you're not making a lot of money doing this.
Well, it's like dog clothes. Gift baskets.
And then you're planning all these hours.
All right. Don't worry. So we know. Come on. How many hours do you have to work?
30.
30.
You don't have to.
You can work no more than 30 hours. So no more than 30, what's the symbol that goes in front of it? Okay. How many hours do you have? How many hours does it take to make a party dress? And how many hours for the other one? All right, so it's 2.5 P plus 1 C. How many total dresses are you going to make? 15.
Equal to at the same.
So P plus C less than or equal to 15. And once again, can we make negative dresses?
No.
So it sets us up again for a first quadrant problem. Draw our graph. I know I'm first quadrant. My first equation, I'm going to do this again. Since P came first, I'll put that as the X, C is my Y, just so we can get in the habit of where our ordered pairs go. When I cover and solve, I have C at 30, and then 30 divided by 2.5 is 12, I believe, right? So I have 30 and 12. Is this graph going towards 0 or away from 0? Moving towards 0. Yeah.
Wait, so why do you have to have a combination of the two? Like, not just a combo, like, why
You're
can't
gonna
you
find-
just have one of all?
And you're going to find that a lot of times, that one of the homework problems you have tonight, you get a maximum value occurring in 2 places.
So you get.
You have 2 choices to go with. It does. You can have it depending upon the objective function that is provided or that you develop. You will find out that every once in a while with these linear combination style problems, your maximum value may occur at multiple locations.
So it means that they're equal?
Yeah, you get the same. You'll get the same bang for your buck if you make one of these 2 choices. So that's kind of a dead giveaway that one of your homework problems does that. As I just said, it does. All right.
Why don't you just do the 1 hour things for 30 of them and you would earn more?
Because you can only have 15.
Because you can only have 15 because your second parameter there. All right. Now the second parameter you have 15 and 15 are your intercepts. That one's pretty easy to go with. Now it's a matter of figuring out, because that one moves in as well, is figuring out that intersection point. That intersection point occurs where those 2 lines had intersected. Now in order to figure out that point, we have to solve that system of equations. So you solve the system of equations. Well, what's nice is that if you look back at the original when we wrote it out, see how it lines up with same coefficient, with same sign right away? Right? The values of C If you have same coefficient, same sign, how do you eliminate the value of C? Correct. So if I subtract the bottom equation from the top equation, I get the following setup. I get 1.5p is 15. Remember, when I'm doing systems part here, trying to figure out their intersection points, I am not worrying about inequalities. I'm just using the equals here. So what's my value of p? It's 10, right? So that means my x value here is 10. Now, substituting back in here, what's your value of c going to be? 5. You agree?
Yep.
So your ordered pairs to check in your objective function become 0, 0, 12, 0, 10, 5, and 15, oh, excuse me, 0, 15. So when you substitute in, this becomes 9 times 0, 4 times 0. You don't make any money. This is 9 times 12 plus 4 times 0, so this winds up being, yes, sir?
If you get to 15p equals 15.
1.5. Excuse me, the dot, because it's on the smaller screen, you might not have seen that. Where that came from here is we're looking at this system of equations to figure out where this point intersected. In order to do that, we solve it, we solve the system. Since you had the same coefficient with the same sign, we subtracted them out. That's where I got 2.5 minus 1. Does that make more sense? Sorry, that little dot, I forget when it's on that smaller screen, it doesn't show up as cleanly. So anyway, we wind up with 9 times 12, which is 108. This one is 90 plus 40, excuse me, 20 for 110. And the last one is 4 times 15, which is 60. So the maximum amount of profit you're going to make is how much? $110. So you made $110 after working how many hours?
30.
This is not a good business venture. That's $3 an hour.
That's less than minimum.
It's a lot less than minimum wage.
Less than minimum wage.
You really, really, really have to love making dresses for dolls. So Jack, please, don't sell dresses for dolls.
Or you could charge.
Or charge a lot more. Okay? This last question on here, unfortunately, I did forget to, when I was cutting and pasting these things, because there aren't that many of these word problems in your book that are somewhat decent to work with. I forgot to put the table in here, so I got to show you guys what the table looks like before you can do the problem. I always do that. So we were talking about granola bars and breakfast bars and things like that. The bottom table. I'm sorry that I cut that off. This is going to be this is a maximum profit problem. It's how many cases of each to give you the maximum profit. So once you figure out the maximum profit, you know how many cases of each. Your production hours. Production hours, let's see, we have the machine hours. And we have labor hours. For the breakfast is 2, 5, granola, 6 and 4. And total, excuse me, maximum hours, 150 and 155. So instead of writing that out in words for you guys in this case, they just showed it to you automatically in a chart. Yeah, maximum hours. So this problem is talking about finding the maximum profit you can make. So as we start this problem out, you're talking about making granola bars or breakfast bars. Breakfast bars, you make 40 bucks a profit. Granola bars, you make $55 in profit. The table tells you that a breakfast bar needs 2 hours of machining, machine hours, and 5 hours of labor hours. Granola bar needs 6 and 4. So the two constraints that you're built upon right off the bat here is how many hours you have to run the machines and how many hours you have to have labor, people working. So the easiest thing to do here is that this table is creating your constraint problem. Can you have more than 150 hours of machines? Can you have more than 150 hours of labor? Can you have negative granola bars? And can you have negative breakfast bars? What's your profit? What's your constraint? Or your objective then?
Maximum profit.
All right, so your maximum profit is going to be defined by what equation?
Equals 40B plus 55B.
Perfect. Okay? That's your objective. After that, these next two setups here are talking about the maximum hours you have for machining. Well, maximum hours of 2 for this plus 6 for that is less than or equal to 150. The labor hours, on the other hand, goes 5 and 4, respectively, less than or equal to 155. Then lastly, what quadrant are you going to be in? The first quadrant problem, because you can't have negative hours or negative, you don't have breakfast bars and stuff. So you only have a little bit left to finish on that problem. And 2 more on the other side.
Is that our homework?
Yep. All right. Now, the very last one on the bottom here, when you're talking about crops, planting soybeans and corn, read through all the instructions real fast, and basically it's asking you to find what is the maximum number of things you can plant for profit. It was trying to get you to break it down into individual pieces. It's just much easier if you just go through it like we have in regular problems. And that one you're going to find out that you can have a maximum in 2 places, just because of the way that the numbers work out. Okay? We will go over these tomorrow. We will be doing some more of these tomorrow as well. I know tomorrow we are supposed to go to the assembly together as a class. So no running off and hanging out with your friends. You're stuck with these people in here. Questions? Sorry, there's no flex tomorrow.
There's no flex.
I know. As soon as we start something really tough, right? No flex.